Welcome to the sample problems for 8.1. And let's start with number 3. All we're supposed to do is figure out, is this direct or is this inverse variation? And if you'll remember from the intro video, they all had a y equals, or both of them had y equals something, and that's really what it depends on. So let's get y equals something and see, does it look like direct or does it look like inverse variation, or does it look like neither? So first let's get y by itself. Let's divide by x on both sides, or multiply by 1 over x. It's all the same. So y equals 1 over, we could put 5x. Okay. If we really wanted to make it look like the sample or the intro video, we could do 1/5 over x. All that matters is that this in the numerator is a constant. So we have a constant up here and we have x down here. This then is inverse. Inverse variation looks like this. Y equals a over x. Something, some number divided by x. And this would be an example of inverse variation. Let's go on to number 4. This is y equals x plus 4. And in neither of those did you see any place for a plus 4 or a minus 2 or anything like that. It was all just a number times x or a number divided by x. That's it. So this would be neither. Okay, because it doesn't fit either of those. Let's go to number 5. Y over x equals 8. And let's just get y by itself, as we did before. So these cancel out, and we get y equals 8x. So this would be direct variation. Okay, that's how all of those go. Just get y by itself. And what does it look like? Does it look like a number divided by x? Then it's inverse variation. Does it look like a number multiplied by x? Then that's direct variation. Does neither of those seem to fit to what we're looking at here? Then it's neither. Alright, let's move on to something different. Number 12. If x equals 5 and y equals -4, and if we, as in the directions, assume that the variables x and y vary inversely, we use the given values to write an equation relating x and y. So what that means is, remember, to say that two variables vary inversely is to say exactly this. This is what it means. Some number gets divided by x. That is an inverse variation equation. So we want to get an equation that looks like this, where this here is an actual number, and y and x are just y and x. We can put something in for x. That means we're going to divide this number by x, and that'll give us y. So we don't know what a is. If we knew what a is, we could just write y equals whatever the number a is over x, and we would be done. We don't have a, but we do have one example of an x and a y. Right? There's lots of examples that would work. We should be able to plug in any x we want and then get whatever y comes out. Okay, so one example is when we put in 5 for x, we get -4 for y. So what would that mean that a has to be? Well, if we just multiply by 5 on both sides, we're just solving for a here, -20 equals a. So apparently we just need to take 20, or -20, divided by whatever x is, and that'll give us y. This is an inverse variation equation. Okay. On top of that, they want us to find what does y equal when x is -3. So y equals -20 over 3. That's not really going to simplify it all, so that would be it. That would be the answer. Okay. That's number 12. Let's go to number 19. So x equals 5/3, and y equals -7. Okay, again, we're looking for this guy here, this equation, which means we're looking for a. We don't have a. If we did, we would be done, but we can find a by saying that -7 is y. if x is 5/3. So now we'll solve for a again. We'll multiply by 5/3. We'll cancel out this 5/3 here. Multiply by 5/3 on this side. And there's no cancellation that can happen here, so negative 35/3 equals a. So our equation, this thing that we were looking for, similar to this problem, is just going to be y equals negative 35/3 over x. That could work. Or we could do negative 35/3x. Whatever we like. So that is, whichever way we choose to write it is correct. And now we want to find what is y when x is equal to 3. So y equals negative 35, I'm going to use the second one here, over 3 times, now we're going to put 3 in for x. So negative 35/9. And that's it. That's the simplest way it can be put. So we found y is negative 35/9 when x is 3. Alright. Stand by. Alright. I don't know why I told you to stand by. It's instantaneous for you. But I paused the video and wrote this down for you. So you don't have to watch me do that. So what they want us to do is find out if these are some sample, say, data points or ordered pairs or solutions to some equation. Then is that equation an inverse variation, a direct variation, or is it neither of those two things? So how could we figure that out? We know that there's this, in any of these equations, any equation, there's a relationship between y and x. There's a way to take x and turn it into y, right? X gets multiplied by some number, or divides some number, or you add some number, or whatever, and you get y, okay? If, specifically, it is inverse or direct variation, there's two possibilities here. If it's inverse, writing in the sky blue for our memory, we're remembering that inverse variation looks like this, y equals a over x. And if it's direct, then it looks like this, y equals a times x. So we need to find out if either it comes from an equation like this, or if it comes from an equation like this. How can we figure that out? Well, we have y and we have x. And so if it's inverse variation, then we should be able to relate y and x by this same a. We should be able to take a, divide it by x, and get y. We should be able to take a, say it's 100, divide it by 1.5, and get 40. And we should be able to do that again and again and again and again. Okay. But we don't want to make a guess at what a is. So another way to look at it is if we can take a and divide it by x and get y, we should be able to, let's solve for a here. We should be able to take x times y and always get a. Okay, let's see if that happens here. Let's, I'm going to grab a calculator, and we'll test whether or not the x times the y will always give us the same a every single time, okay? So let's see. If these two were related by an inverse variation, then we'll get some value a when we multiply them together. So 40 times 1.5, 60, okay? So if it's inverse variation, then the equation would be, just based on this one example, this particular problem would look like y equals 60 over x. We should be able to take 60 divided by x, and we always get whatever the y is. Or, like we said, we could take x times y and get a. So we should always be able, for all of these, if it's inverse variation, take x times y and get always 60. Okay, that's the important part. So let's take 2.5 times 24, and we get 60. Great. Put 60 there. 4 times 15, we get 60. 7.5 times 8, that's 60. Always have to check every single one of these, and that's 60. 10 times 6 is, of course, 60. So we get 60 here, and here, and here, and here. So since we get 60 every single time, we have proven that we could take 60 divided by whatever x is and get whatever y is given. So this one, number 20, is inverse. Okay, let's do 21. Okay, there it is, 21. They wanted the same question. Is this inverse variation? Is this direct variation? Or is it neither? So let's try the same approach as we did for inverse variation. We'll take x times y and see if we get the same number every time. So let's bring up the calculator. 12 times 132. I didn't do that right. 12 times 132. Okay. 1584. So we get 1584. Okay, let's try it with the next one. 18 times 198. 3564. So already we know it couldn't possibly be inverse variation, because for these two, the equation would be y equals 1584 over x. But for the other one, the second one, this goes to there, this one would go to this equation, y equals 3564 over x. Those are two different equations that the same equation can't govern all these ordered pairs, all of these results. So that's not going to work out. It's not inverse, but maybe it's direct. So let's take a look at inverse variation, or direct variation. If they're direct, the constant is now multiplied by x. So we should be able to take x, multiply by a, and get y. Or, using the same kind of reasoning here, if we can always use the same a, we, let's say, divide by x on both sides. Now y divided by x should give us a every time. Okay, so we'll take y divided by x, see if we get the same a every time. So let's try that again. 132 divided by 12, 11. Okay, so that gave us 11. 198 divided by, no, that didn't work. 198 divided by 18. 11 again. Okay, let's just keep trying this over and over. 253 divided by 23. 11. 319 divided by 29. 11 again. And 374 divided by 34. It's 11 every time we get 11. Every time. So, since that happens every single time, we can always take y divided by x and get a. So y divided by x is always 11. So y equals 11 times x. You know, if we just multiply by x on both sides, get y by itself. So, there we go. That is an equation that relates x and y. Let's go over to 22. Let's get this color here, 22. Okay, so again the question is this direct variation between these variables, or is it inverse? And to answer that, let's start out assuming that maybe they're inverse. So we'll try 16 times 4. Okay, if it's inverse variation, then that would mean that a is 64. Okay, so we should get 64 every time. Then we'll take 11 times 5. Do we get 64? No, we don't. We get 55. So it's not inverse. That's out of the question. But maybe it's direct. Maybe we could take y divided by x and get the same thing every time. So we'll take 16 divided by 4. That's 4. How about 11 divided by 5? And that's not 4. So it's not either. It's neither. Okay. So there we go. Number 25. Just going to do one from this little problem set because joint variation will soon be out the window. Okay, so it says specifically z varies jointly with x and y. So if z varies directly with x and y, that means that z equals, here we're remembering this. That means that z equals some constant number times the variables x and y. So we could say, to find a, z is 12, and that equals a times whatever you want for x, which in this case is 8, times y, which is 6. So 12 equals a times 6 times 8, which is 48. And then solve for a by dividing by 48 on both sides. 12 over 48, which is 1 over 4. That is a. So the equation is z equals 1/4, that's a, times whatever x and y are. Okay, so you just throw in your x and your y, and then multiply by 1/4, and you find out what z is. So then it asks us to find z when x is -4 and y is 5. So x is -4 and y is 5. 1/4 times -4 is -1, and -1 times 5 is -5. So z is -5 when x is -4 and y is 5. And that is a quick little joint variation example. That is everything. So remember, this is just a quick little intro into what is really important for the rest of this chapter, which is inverse variation. That's going to lead us into rational functions, graphing rational functions, and so on. So pay special attention to the inverse variation, x being in the denominator, and that will get more and more filled in, more and more fleshed out in the future videos. Thanks for watching.